Hello everyone, I am Neil Trevitt, President of the Khronos Group and OpenCL Working Group Chair at Khronos, and I'm going to present a high-level overview of the Khronos family of compute acceleration APIs that are used in a variety of application areas, including machine learning, vision, and speech processing. Khronos develops multiple standards for parallel compute acceleration, providing a choice of APIs that are suited to different markets and developer needs. The bottom row on this slide are APIs that provide low-level, explicit control over accelerator hardware. Vulkan is used for programming GPUs, and OpenCL enables software to use any mix of available heterogeneous processors. Both OpenCL and Vulkan provide parallel acceleration of shaders or kernel programs compiled to Khronos' SPIR-V intermediate language. Sql and OpenVX on the top row of the slide are higher-level programming frameworks for increased application portability across diverse processor architectures. Sql provides parallel programming using standard C++, and OpenVX uses a graph abstraction to express vision and inferencing functionality and can directly import trained neural networks in the Khronos NNEF format. Sql and OpenVX may be accelerated by the lower-level Khronos APIs, but that is a choice that's left to the implementer. Now let's discuss a little more detail on each of these APIs. Firstly, Vulkan is a modern GPU API that provides more direct, low-level control over GPU hardware than the previous generation OpenGL. Although primarily known as a 3D graphics API, applications can use Vulkan for GPU compute with explicit control over memory allocation and thread management, and can use multiple queues to feed compute operations into GPU hardware. Vulkan ingests shader programs in Khronos' SPIR-V intermediate representation, enabling the use of multiple front-end compilers for languages such as GLSL and HLSL. OpenCL is a runtime and programming framework with C and C++ based languages for creating compute-intensive kernels that can be compiled and executed in parallel across any available processors in a system, including GPUs, CPUs, DSPs, FPGAs, and custom accelerators. OpenCL provides APIs to discover accelerator devices, compile kernels for selected devices, execute those kernels with explicit control over kernel placement, memory allocation, and synchronization, and finally gather the results. When deciding between OpenCL or GPU APIs such as Vulkan, many developers that don't need graphics rendering find that OpenCL provides a simpler programming model, a lighter weight runtime, and more rigorously defined numerical precision that can be critical for many compute markets. As well as being used directly by applications, many libraries, frameworks, and compilers use OpenCL and Vulkan as back-end targets. For example, many machine learning compilers apply graph-level optimizations to imported networks, and then lower those networks into executable OpenCL or Vulkan code for cross-vendor access to hardware acceleration. This means that many developers using high-level frameworks such as TensorFlow may well be using Khronos APIs for compute acceleration, even if they don't realize it. Much of the language flexibility for Khronos APIs is a result of a robust open-source compiler ecosystem leveraging Khronos' SPIR-V, which plays a vital role in the Khronos standards family. SPIR-V is an intermediate language representation that includes heterogeneous parallel processing and graphics operations that can be broken down into instructions for GPUs and other processors. SPIR-V is the only language directly ingested by Vulkan, and it can be imported into a growing number of OpenCL implementations. SPIR-V enables the hardware and compiler communities to innovate independently as front-end compilers can simply generate SPIR-V code to be ingested and executed by a wide range of runtime APIs. Now let's look at Sql. Sql is a C++ language framework that uses template libraries to dispatch selected parts of standard C++ applications to acceleration processors. Sql enables complex C++-based applications and libraries, such as complete machine learning frameworks, to be directly compiled and accelerated to performance levels that in many cases outperform hand-tuned code. Offloaded C++ code is sent to the Sql compiler for the targeted accelerator processors, often using OpenCL as a backend, but Sql is increasingly supporting a wide variety of backends for deployment flexibility. The unaccelerated remainder of the C++ code is sent to the standard C++ compiler for the host CPU. Sql is gaining industry adoption in desktop, embedded, and HPC markets. For example, the DPC++ language, which forms a key part of Intel's One API initiative, is an implementation of Khronos' Sql standard. OpenVX graphs enable a developer to program complex vision algorithms by simply connecting a set of predefined functions or nodes. OpenVX enables inferencing acceleration alongside classic vision functionality and is increasingly being used as a portable inferencing engine. OpenVX accelerates inferencing by defining nodes to represent neural network layers and a set of tensor and tensor operations to represent classes of neural networks, typically used in edge inferencing. OpenVX can import a complete trained network in the Khronos NNEF Neural Network Exchange format, imported from machine learning frameworks using Khronos open source tools. NNEF's unique value is that it provides a stable specification to be directly imported by hardware drivers. Increasingly, Khronos APIs are being used in a wide range of markets where reliable, deterministic graphics and compute acceleration is essential, including the automotive market where formal safety certification is required to meet international standards such as ISO 26262. Khronos is evolving a set of safety-critical APIs that reduce system-level certification costs by creating streamlined versions of widely adopted desktop APIs. The safety-critical versions of these APIs focus on the needs of the embedded market and provide rigorously defined deterministic behavior to simplify system design and testing. Actually, Khronos' experience with safety-critical APIs goes back to 2003 with OpenGL SC 1.0 for avionics displays and OpenGL SC 2.0 in 2016 for the automotive market, and in March 2022, Khronos released Vulkan SC 1.0. Desktop Vulkan is a compelling API point for creating a new generation of safety-critical standards as it has reduced driver complexity compared to OpenGL, and Vulkan SC further reduces driver size while strengthening API determinism and error handling. OpenGL and Vulkan are not the only Khronos safety-critical APIs. OpenVX has a safety-critical profile for offline compilation of OpenVX graphs into vendor-specific binaries for direct import into the runtime, significantly reducing API complexity. The safety-critical profile is generating significant interest in OpenVX as a cross-platform inferencing engine for safety-certified systems. Khronos is now exploring the industry need for a safety-critical version of the Sql API using Khronos' proven exploratory group process that opens participation to all to determine if there is a consensus on industry requirements before starting a new API design. The Sql Safety-Critical Exploratory Group is currently meeting weekly to generate a scope of work document that would be used to guide a new Khronos working group if approved by the Khronos board. If a Sql SC API could be of interest to your company, you are invited to join the exploratory group at no cost to participate in the discussion. Finally, a brief introduction to the new Khronos Camera API working group that was created in February 2022 after Khronos ran an exploratory group throughout 2021 working together with the European Machine Vision Association. This group is so new that it doesn't yet have a name or logo. The Camera Working Group is addressing the lack of an open standard API for portable control of embedded camera runtimes. This is increasing the cost of integrating a widening diversity of camera sensors, and has become a major constraint on innovation and efficiency in building vision-based systems. The Khronos Camera Working Group will provide a cross-vendor, low-level API for sophisticated control over sensor stream generation to feed any of the acceleration APIs that we have been discussing today. So, thank you for listening to this presentation, and I hope it gives you enough insight into the family of Khronos Compute APIs so you can find out more details about the standards that may best suit your requirements, and starting with the links provided here. As always, any company is welcome to join Khronos for a voice and a vote in developing any of the standards that we have covered here today. Thank you.
Hi, I'm Michael Wong. I am Sql Working Group Chair and CoPlay DE, and I am happy to have the opportunity to speak here today to give you an overview of Khronos Sql. So the latest version of Sql is Sql 2020, which launched in February 2021 to bring a new level of expressiveness and simplicity for developers who wish to program heterogeneous parallel processors using modern C++. The result of 3 years of work, Sql 2020 aligns closely with ISO C++ 17 to simplify porting of standard C++ applications, while backwards compatible with previous Sql versions. Sql 2020 provides significant new functionality for improved programmability, smaller code size, and faster performance, and is consequently being widely adopted in desktop and supercomputer markets, as well as embedded systems. Sql is a C++ language framework that uses template libraries to dispatch selected parts of a standard C++ application to acceleration processors. Sql enables complex C++-based applications and libraries, such as complete machine learning frameworks, to be directly compiled and accelerated to performance levels that in many cases outperform hand-tuned code. Offloaded C++ code is sent to the Sql compiler for the target accelerator processors, often using OpenCL as a backend, and increasingly supporting a wide variety of backends for deployment flexibility. The unaccelerated remainder of the C++ code is sent to the standard C++ compiler for the host CPU. Sql is gaining industry adoption in multiple markets, including embedded and HPC. For example, the DP++ compiler, which forms a key part of Intel's One API initiative, is an implementation of Sql. So here you see an overview of the Sql implementations and the many platforms that they support. If you look across the bottom, you'll see the many different kinds of platforms that are now supporting it. It's ranging from Intel to AMD to ARM Mali to Imagination's Power VR to Renesas RCAR, Xilinx, as well as NEC vector engines and Huawei AI processors. This highlights the already large and growing Sql ecosystem, starting with the implementation on the left. We also have the many different research projects in the middle column, and then also books on the right and benchmarks. Of the books, I will call out that there is now a book written by James Rinder, renowned author, that covers One API and Sql. And on the far right, there are many libraries for linear algebra, machine learning, and parallel acceleration frameworks separated into the domain that they serve, from BLAST, FFT, Math, Random, Solver, Sparse Matrix, Tensor, and STL. And at the bottom, you will see the working group attending the meeting calls. So we see how Khronos standards can be used in a typical mobile or embedded application, needing vision or inferencing acceleration. Neural network training typically occurs on high-power desktops or servers at high precision, using large training data sets. The resulting trained network encapsulated in an NNEF or ONNX file can be imported into the target system in two ways, either ingested into an inferencing engine like OpenVX or passed into a machine learning compiler to generate code that executes inferencing operations. Either the compile code or the inferencing engine API is linked into the application, which may also use the Sql compiler to generate additional parallel code if the application is written in C++. We're also going strongly to support safety critical. We ask that you join Sql SC exploratory forum, with the aim of forming a Sql SC working group. These allows neural network models that are trained in the cloud using a variety of frameworks to be ingested eventually by Sql for safety critical reasons. Okay, now here are some Sql customer quotes using Sql for embedded automotive AI and safety from Renaissance, NSI Techs, Xilinx, and Imagination. So how is Sql used in HPC? These days, HPC workload persists for 20 years while hardware can change every 5, often to different vendors. And they need to serve these 3 pillars of science. Traditionally, they have been supported by the top 3 set of languages, OpenMP, mostly for C and Fortran, Max-CUDA, OpenACC, and OpenCL, and now for C++ Sql. The development workflow for these science problems are usually 3 steps, but the thing that Sql and C++ like framework brings is that now you can adapt the algorithm at step 1 when you choose the algorithm, so that you can have control over the data layout, data movement, data locality, and affinity, so that your code can be performant. And here are some Sql customer quotes using Sql for exascale or pre-exascale computers from Argonne and Chineka. And here are some more Sql customer quotes using Sql for HPC from University of Innsbruck, Salerno, NERSC, LBL, and Intel. And finally, how do you join Sql? I'm glad you asked. Membership is open to all, and 3 of these don't need any money, including working on the public GitHub, public contributions to the specs, and being part of the advisory panel, which meets 3 to 4 times a year. Thank you and have a great day. Bye-bye.